far in our programs, we've been utilizing variables and functions. Now that we're getting into object-oriented programming, we're going to begin making our own data types. To do this, we defined structs or classes. More on classes later. Both of these can contain their own variables and functions internally. Object-oriented programming is one of the strengths of C++ and similar languages. It helps us create models of data, grouping like things together. By grouping this information together, it also becomes easier to read the code, more manageable to maintain, and it makes it possible to extend your code in the future when you're adding features. Think of objects almost like nouns, and our noun or objects have functionality and attributes, so they have verbs that they can do and adjectives that describe them. So, for example, some game objects, you could have a game character who has a position on the screen. They have a bitmap for what they look like, and maybe a speed that they can move at. For a shopping cart, you might have a list of items in that cart, where item would also be another object. You could also have the shopping cart be logged in as a user. It just depends on how you want to design it. Here are some example objects and their variables and functionality. So for a video game character, they'd have XY coordinates on the screen, a bitmap image, maybe experience points, or a maximum speed. Some of the functions might be to move in some direction, to take some amount of damage, or even just to animate the sprite. For a text file, you might have file name, last update date, and its text contents. And for a function for a text file, you might have something like read a line of the file, add a line to the file, save and load. Here are some more examples. What are some things around you that could be turned into software or abstracted into data? What are objects and their functions? I have a lamp on my desk. It can turn on and off, and it has a light bulb, and that's another object. Maybe the attribute would be the wattage of that light bulb. With structures, we'll group together small amounts of information, like we can make a coordinate pair that stores an XY coordinate. We can have a rectangle that stores XY width and height. We can store a fraction with a numerator and denominator. And part of the perks of using a structure is that you can pass the whole structure object to a function, rather than just passing, like, say, numerator and denominator separately. Classes will end up being better for larger, more sophisticated objects, but both classes and structures can store variables and functions. We will create our struct objects outside of any functions, including main. It begins with the keyword struct, followed by the object's name. The members of the struct are declared or defined within the curly braces. The end of the struct definition must have a semicolon after the closing brace. After a struct has been created, we can create a data type of that object in our program. Here we declare a variable of type rectangle and name it box. To access the internal members, the variables and functions, of our custom object, we need to use the dot operator. Because a custom object can contain many variables, arrays, or just generally take up a lot of memory, you should make sure to get into the habit of passing any objects by const reference into other functions. Unless you actually need to change that object, then just pass it as a reference. Let's write some code to demonstrate how to use structs. Alright, so we've worked with slope a few times, just calculating from two coordinate pairs. This time, let's actually create a struct for a coordinate pair. So we open with curly braces and close, and we have to make sure there's a semicolon at the end, otherwise we'll get a build error. So our struct can have the XY coordinates as part of it. When I create a coordinate pair down here, and say first dot x equals some value, first dot y equals some other value, and that's just how you would access internal members of the coordinate pair class. So we have a coordinate pair variable, its name is first, and then we can access other members inside of there. So let's have the user enter the coordinate pairs. Enter an x, y coordinate. we can have them input first.x, first.y, and then we can do it again for the second one. But now this is kind of redundant, like we've entered the same message both times and we're just getting the same information just from different versions of the coordinate pair. So instead, let's actually do this. Let's create a get user input function. And instead of having these out here, I'll put it in here. Now, first is not a variable now. We're inside of the coordinate pair. So we'll just input to x and y. So whenever we declare this, we can use this function. It will affect only, like if we call first.getUserInput, it'll affect only its own variables. And then we can also call second.getUserInput. And then let's also have just display so we can view them kind of nicely. So we'll have like open parentheses x, comma, y, in parentheses, and I'll just end that there. So then we can say, you know, first is first.display, second is second.display. So let's run this. Okay. Oh, yeah. So this is not actually returning anything, it's only displaying some information, so I have this wrong. We need to do a cout first, call display, do another cout, then call that display, and then do another inline. So run, enter an xy coordinate, 1 and 2, 3 and 4, so then it will output it nicely for us. And it's taking care of assigning those values. So now we have a very consistent way of getting the user input. We don't need to keep copy pasting this label. If we do a lot of copy pasting in a program, it's likely that we're going to end up with errors, or in the long run, if you're wanting to go back and edit it later, it's likely that you'll miss a spot. So there's a big chance of things being inconsistent. Okay, so we want to get the slope, and normally you'd have second.y minus first.y over second.x minus first.x, and that will work here. But this is kind of clunky as well. We know that to get a slope we need a coordinate pair, so let's create a function, get slope, and it will take 2 of these coordinate pairs. Now I'm going to pass them as constant reference because you just want to get into the practice of doing that with any objects, because objects have internal members, so they can be very costly to copy over because it's not just a coordinate pair, it's going to be also 2 floats. And while this one's really small, there could be more complex classes down the road where you have arrays, strings, other objects, and it just becomes bulky. You don't want to copy it. So I don't want to change these. I'm just going to use them to calculate, so that's why I've made them const. We can return 1.y minus 2.y over 1.x minus 2.x. So here, instead of calculating, we can say get slope. We'll pass in our first and second, and then we should be able to get the slope back. There. So again, this handles something for us where we don't have to keep copy pasting this formula everywhere. We just have a get slope function, and we pass in 2 coordinate pairs, and it takes care of it for us. Okay, let's implement a rectangle. So I already have a get random thing here. That's just so I can generate some random coordinates for our rectangle. We'll say struct rectangle. Remember to put the semicolon at the end. And inside, We can have ints or floats. I'm just going to go with ints for now. Width and height. So then down here, we can make our rectangles. Rectangle. Let's make a few. Let's have 5. So I is less than 5, I plus plus. We can set the values of these by saying rect, like 0, or, well, this should be I right here, is equal to some value, so we can say get random. And let's say it's between 0 and 10. Same for the y. And then for width, let's have it between 2 and 10. And same for height. So we can set all of these just like that, and then we can also output this information, but it'd be kind of a pain to have to keep, you know, chaining these all together and making it look good. Instead, let's create a function in here called display. So it's not going to draw a rectangle, we're not going to do that. We're just going to output its information. So cout, we'll do the little coordinate pair, so x, comma, y, and then let's also do the width and height. So I'm going to put a space here, so or a tab, so it'll look nicer. So we'll have width and then by height. So that will handle outputting all nicely for us. So we can say rect I dot display. We run it, then we get a nice output of our rectangles. So let's also create a setup function. So void setup, int x, int y, int width, int height. Okay, so instead of setting all of these up separately like that, instead we can call setup, and it's going to want them in the same order, so x, y, width, and height. I'm just going to move these into here. You can call it a bunch of times. So you'll see the little hint that shows up as well. It'll tell me the order that it's expecting these to go into. Okay, so we haven't implemented setup yet. Now notice here with display I just have x and y, and that's okay, it'll output that fine. Here I've created my parameters and they match the actual member variables. They have the same name, so there's like a naming conflict. I can't, you know, it won't really know what I mean by x. It'll pretty much assume it's just this x. So if we want to say the rectangle's x is equal to the parameter x, we can use the this keyword with an arrow and set it to x equals x. So this one is referencing that x, and this by itself is referencing the parameter x. Now, I wouldn't need to do this if I name these something else, so I could say like x equals dx now. But if you just wanted to keep it consistent and have the parameters match, you could do this. This width, this height. Okay, so we've already called this function and we're passing in a bunch of random stuff, so we can run that now. Okay. Now we have x, y coordinates and the width and height. What if we want, basically it's top left corner, what if we wanted to output the coordinates of every corner? Well, we could say something like int get x1, or maybe we could say this is get x, and this would be the left corner. I'm just putting an underscore because it's harder to read that with all like that. Okay, get x left. The left corner is going to be the x coordinate. Get x right. So we'd have excuse me, the x coordinate plus the width would be the right side of the rectangle. Say get y top, so the top is just y, and get y bottom would be y plus the height. So if we wanted to output basically the coordinates for every rectangle, so we have that. Let's just say we'll do another loop. We can say let's do inline top left, and we can get the left position, and then the right, or the top, get y top. So these will be coordinate pairs. I'm going to make these have parentheses around just so they look a little nicer. Then we can do top right, so get x right. And we can do bottom left and bottom right. Okay, so y bottom. So let me also put rectangle number I. Now when we run this, it doesn't like something. No match operators. See out. It looks okay to me. Unresolved, overloaded. Okay. Get x left. Get y top. Oh, I didn't put these parentheses here, and it doesn't like that. To call the function, we actually have to have the parentheses. There we go. Alright, so rectangle 1, and we have these. So I wonder if I could draw this in Wolfram Alpha. We can check out what they actually look like. So let me look that up real quick. So let's see if we can just plot in these points. 5, 16, 13, 16, and maybe it'll make us a nice graph. Okay, so see here, it has top left is at 5, 7, so let's see, we're at, well, okay, maybe, what? What? Okay, so if we were actually to graph this, we have some graph paper. You can say 5, 7, so 5 and then 7. We have top right is at 13, 7, so that's right here. It would go there. The bottom right would be 13, 16. So actually, I think I calculated this wrong. Because 16 is going to be, well, okay, on this graph, it's higher up. But on a computer, shit, fuck me. Okay, so say we have a graph like this, and with a computer the origin is at 0, 0. So our top left angle our top left point is 1, 2, 3, 4, 5. So it's over here, and then 1, 2, 3, 4, 5, 6, 7. So this is where our first point is. Then the top right, it'll be at 13, so that's 5, 6, 7, 8, 9, 10, 11, 12, 13. it'll be over here. So those two would be connected. Bottom right would be at 13, 16, so that would be even further. 7, 9, 10, 11, 12, 13, 14, 15, 16. So that will be down here. That's the bottom right. And then the bottom left will be at 5, 16, so that's just going to be right over here. So that's what the rectangle would be like. You have x, y, and then you know the width and height, so this is x plus width and y plus height. And you can get the rest from there. This is x plus width with the same height, with the same y. This is x, but then y plus height, and so on. So alright, now let's create a struct for a class. Not a literal like C++ class, which this is a keyword and we can't use. I mean like a course. So maybe a course would be a better word. Because in C++ a class is a specific thing. And then you can say that you have a class name, maybe the class ID. You could have total students, and we'd also possibly want an array of students. But we don't have that yet. So you can also display a class summary, display class summary, and we can output each student if we had those. But let's just start with the class name. Name, ID, total students, total. Okay, so we can create a class, or course. My course.name is CS. Let's just call this 123. My course.id is just going to be 456. And we can set the total amount of students manually, but let's wait on that. So let's say my course.display class summary. Run the program, and it'll tell us our information. Okay, so now I kind of want to have a student class or struct. So we'll create a student struct. Each student will have a name, and they'll have their own ID. And a student might have a set of assignments that they've done, so like we can't really calculate grade or assignments quite yet, but we at least have a student. So student, and we'll have an array of students. We'll have a maximum of 30 students, but based on what this is, every time we register a student, we'll add that. So let's have something called register student. And when someone's registering a student, we want to get the student's name, and we will generate an ID for them. So they're creating a new student. We're going to say our students. Now total students will start at 0, and we'll add to that every time we add a new student, so we can use that as the index. So I'm going to say name is equal to name, students, total students dot ID, and we'll just set this equal to whatever total students currently is, but let's add 100 so it looks more like an ID. So it'll be 100, 101, 102, 103, and so on. So down here we can say my course.register student, and we'll have Albert. And up here, let's go ahead and just output the students we have. So I is 0 until the total students, not until 30. And of course we could do an if statement to check to make sure we're not going over 30 here. But we will output each student information. So let's tab over, output the student, current one we're looking at, their ID, and then let's do another tab and output their name, student's I.name. Okay, so if I run this, I get a segmentation fault. Where do I get a segmentation fault at? let's check this over here. Alright, so total students. Okay, one of our problems is this has not been initialized. So I'm going to put a breakpoint right here, just for the sake of debugging. It should be paused around here. I need to debug, and I know what's wrong, but I'll show you. I did not initialize total students to some value. So let's have total students. So it initializes to garbage. And this is one of the problems. You want to initialize your values. So before we do any of this, let's also just create a quick setup function. And total students absolutely needs to be initialized. So when we create my course, we'll have to call setup. Actually, while we're at it, we could set the name and ID like this as well. So we could say int ID and then const string name. So we'll just set the course name, and we have to use this name is equal to name, where this arrow name references this, and this name here is that. We do this because I just made a naming conflict because I have both of these matching. This ID equals ID. So here, we're passing in the ID first, 456, CS 123. Okay, now it shouldn't crash. Okay, so here's the student number 100, Albert. You can keep adding people, and I'll show them all. And these aren't very good names for the different people, so we'll just put in some stuff. Okay, so we have a class. That class has some amount of students. Now, what if our students, we want to calculate a grade? Maybe we'll have assignments. So struct assignment. String, let's just name like the title so we can use it as a reference. We can have the total points it's worth, and maybe the attained points. So each student will have a series of assignments. Each of those assignments has total points, and then something that they have scored on it. So then we can also make a function that will turn it into a percent for us. Return attained over total times 100. Now we can get, is this 89%, 20%, whatever. Back in student, we can now have an array of assignments. And let's say everyone has 10 assignments they've done. And so let's create a function that will kind of initialize this with some data. So I'm going to create something here. We're just going to call it populate information. We'll pass in the class by reference. Oops, I mean course. So we're just going to load a bunch of sample test information into our course and our students and their assignments. We have a course, we have a few students. Let's say we're going to input, let's use random numbers. So first let me create a random number generator. Int get random, int minimum, int maximum. This is just so we can get a random amount of people, a random scores, that sort of thing. So int diff equals maximum minus minimum, return rand diff plus minimum. And we have our libraries up here. And we'll want to seed it. srand time null. Okay. So get random, so total students equals get random between 10 and 30 students. So for int I is equal to 0, I is less than the total students, I plus plus, and we'll set these up. So course dot students at position I, and we can say dot register. Oh, I should just say dot register student, and give them some sort of name. So at the moment, this will just Let's get rid of that. I'll say populate information. If we want some random names, we're probably going to have to make a random name chooser or something. So string get random name. And this is going a little bit off tangent, but if you were writing a program where you could randomly populate your program with information to test, this is good to do. So I'm going to look up random name generator. And I know this one can do random names, and we'll do either, and I thought there was a way to get a surname as well. Oh well, we'll just have it generate names for us. So, get random name. I'm going to do 2 random names, so first is get random between 0 and 10. Last is get random between 0 and 10. And then we'll have string name. Keep it empty for now. If first is equal to 0, we'll add that name. So I'm just going to populate all these real quick. Okay, and return name. So we could have a random amount of names and just kind of keep generating those, but this is okay for now. We're going to register a student. When we register a student, we need to have their name, and that's all we need to pass in. So where am I? Oh, I opened a different file. There. Okay. So down here, register student, get random name. Now if we run the program, it will get an error because populate information didn't pass in my course. Now if we run, okay, we got another error. Oh, I didn't pass in, I meant to get random name, not get random. Okay, so now we have these students. We have 26 students, and they all have random names. Okay. So, beyond their names, I want to set up their assignments. So, for each student, they each have 10 assignments. For int a equals 0, a is less than 10, a plus plus. So, we'll say for course.students at this position, dot assignments at that position, we will make it some random number. So, get random between, let's say, 60 and 100. Now, also remember, assignments has total points and attained points, so I'm going to name this attained points, and we're just going to make the total points equal to 100. And we could give it a name also, but I guess we could say, just to give it something, dot title is equal to, so we have a from 0 to 10. Our ASCII characters start at 65. So I'm going to say 65 plus a. So really the title will just be like A, B, C, D, E, and so on. Okay. So we have our students, we have assignments. It's not outputting any of their assignments right now. So let's say we want to display their average when we're displaying all the things. So we have get percent here, but let's say float get average. So we'll need to have a sum, and we'll go through all the assignments, add those up. Sum is added assignments of I. Then the average will be the sum divided by 10. And we'll return that. So down here, we can also say tab and students I.getAverage, and I'll put a % at the end because it doesn't have that automatically. Run. Okay, I forgot to put dot attained points, or no, we can do get %. So remember, get % gives us some percentage. We'll just average the percents together. Run. Okay, now this is kind of off, but now we have those. I'm going to put these before the student. So tab, and probably another tab. There. So that looks a little bit better. List of all their students and their scores. Okay, now if we want to get the letter score of that, so char get letter grade, let's say we can get the average equals get average. So we can call this function from within this function. Then we'll just say if average is greater than or equal to 90, we'll return A. Else, if it's greater than or equal to 80, we'll return B. 70, C, 60, D, and otherwise, we'll just return an F. Okay, so we can output the average, and let's output the letter grade. And I'm going to separate these on different lines so we can actually read them nicely. So there we go. We got student averages and grades. So this might be a way you would write something to manage students. You could have a database, or you could just store it to a file and output information. So we started with our course. Our course has an array of students. Each student has an array of assignments, and assignments have what they need to let us calculate their score. We could also make this more sophisticated by actually having, a menu where it's like, well, add students, add assignments, add scores on those assignments, and kind of manage and take care of all of that. But for now, this is good enough. We just have a simple list. Got some random data populated, random scores, nobody got an A, so that kind of sucks. But there you go.